Okay.
All right, what can I help you with?
$104.
Okay. Can you see my screen?
Yes, sir.
All right. So I believe if we try graphing this, it's going to look like this. Because if you set the bottom equal to 0 and you solve for x, you get x equals -5. So it's going to have a vertical asymptote at -5. There's a negative in front, so that means instead of the regular way, your asymptotes will be, your branches will be in this direction. And we can always check in a minute on Desmos or your graphing calculator to see if it matches with mine. So let's do that. Yep, looks like it, right?
Mm-hmm.
Here's that -5, here's this branch over here, and here's the other branch going this way. So it's telling you what is the limit of that picture as it approaches 5 from the left-hand side Is it 5? That should be a -5 actually. So change that to where it says the limit. Here, I'll write it down. The limit as x approaches -5 from the left-hand side. So if we approach -5 from the left-hand side, it's right here. So what am I approaching?
Infinity.
Right. So that's the answer. Equals infinity. What else?
$31.
Okay. $31. Find the domain and range of each function. Write your answer in integral notation. Okay, so we have f of x is equal to negative square root of x plus 3. So this really works if you graph it. We know that a radical function looks like that, correct?
Yes.
This plus 3 means it's in there with the x, so you're going to move it to the opposite, left or right. So it's going to go to the left 3. It's going to look like this. And this negative in front means that it's going to be flipped. So it's going to be that picture. So our actual picture that we're going to be looking at this one. And if you didn't know, again, go to Desmos or your graphing calculator, type it in. See how it is?
Mm-hmm.
Okay, so what is the, let me erase this very quick. So by looking at our picture, what is the domain?
-3.
-3.
To infinity.
Right. To infinity. And what is our range?
0.
That's right. Here's our domain. The red bars are my domain. So it's going towards infinity, right?
Mm-hmm.
Mm-hmm.
Here is my range. Range is the y-axis. So it's going towards where? Going down and down and down. What is that?
negative infinity.
Right. What else?
$66 with minus pi over 4. That would be the horizontal shift, right?
Yes. What else?
44.
Four. Okay.
I started, but I think I was doing it wrong.
Did you at least get the slope?
Is it -1?
Let me see. 1, 2.
I think.
So slope is y2 minus y1, so 2 minus 6 over 1 minus -3. 2 minus 6 is -4. Positive 4, so it's a -1. That's right. So then you use y minus y1 equals x minus x1. I'm going to use the one that has positives. So y minus 2 equals -1 times x minus 1. And just like that.
Oh, that's it?
Yeah. What What else?
With 28, would you add 3 to both sides of the equalities?
Yes. And then divide by 2 on both sides. Yes. What else?
On 75, the next step would be sine squared of x plus cosine of x equals 0.
What did you say the next step was?
I was asking, would it be sine squared of x plus cosine of x equals 0?
No, there's an identity out there for this.
No.
That one has 3 different identities. We're going to use this one. Cosine squared of x minus sine squared of x. And then we're going to bring down everything else. So we're going to bring down the sine squared of x. And then the minus cosine of x. That's going to make it easier because something cancels out. What cancels out?
The signs.
The sign.
The sine squares cancel, leaving you with cosine squared of x. Hold on right quick. I got a phone call. Hold on right quick. All right, it wasn't important. So cosine squared of x minus cosine of x equals 0. And what do they have in common? They have one cosine in common. So factor it. Set each one equal to 0 and solve for it. You can do that, right?
Mm-hmm.
So you have cosine of x equals 0 and cosine of x minus 1. So where's cosine of x? 0. I can do this one. Cosine of x is 0 at pi over 2 and 3. And then you can do the what else?
I have a question.
Mm-hmm.
When the radical is taken, do you give the positive and the negative result?
What do you?
Sir?
What do you mean?
Like for the answer. Like for 75 I got pi over 2, 3 pi over 2, and then I got 2 pi. The positive and the negative. Yes.
No, because this right here is saying, right here, is this what you,
Mm-hmm.
it says, where is cosine, or in other words, your x-coordinate, where is that 0? So if you look at the unit circle, here's my unit circle. My x-coordinate is only 0 right here at pi over 2, and my x-coordinate is only 0 right here at 3 pi over 2. Then the next one is going to say, if you solve for x, it's going to be cosine of x equals 1. So that means where is cosine, or in other words, your x-coordinate, where is it 1? Where it's only 1 right here at 0. And that's it. But we know that 0 is also the same thing as 2 pi. So go ahead and also put it in there. So it's going to be at 0 and at 2 pi. So just go ahead and place them in there. Even though we know that 0 is 2 pi. Same thing. What else?
That's it for me. I didn't really have any more questions.
Okay. 7A?
102, and that's the last one.
Okay,
would you get? Oh, never mind.
so for this one, I would use the table. So you're going to pick values to the left of 3, but that are very, very close to 3. So I would say, negative 3. So I would say negative, wait, hold on. To the left of 3? Negative 3. To the left of negative 3. To the left of negative 3, we got to be careful though, right? Because here's negative 3. To the right of negative 3 is negative 2. To the left of negative 3 is negative 4, right?
Mm-hmm.
So we're going to want negative 3.01, negative 3.001, negative 3.0001, and negative 3.00001. And then just plug them in and get an answer, and then from your answers you're going to figure out where it's going at.
Okay.
Got it?
Yep.
All right. Well, I'll see you all next week.
Thank
Okay.
you.
All right. Have a good one.
Thank you. You too.
You too.